Now we're going to be talking about matrices and operations on those matrices. So just as a little introduction, this is an example of a matrix. It is this grid with multiple rows and or columns, and each thing that is inside of our matrix, that is called an element. Now why do we even care? These are different fields of study that use matrices, so if you find yourself going into any of these, knowing about matrices is going to be very helpful. Now, when we're talking about a specific matrix, a row is a horizontal line in the matrix. So here, this top row is -2, 3, and -1. The second row is 1, 4, and 7. The third row is 6, -5, and 2. Then we also have columns, which are the vertical lines in a matrix. The first column is -2, 1, and 6. Second column is 3, 4, -5. And the last column is -1, 7, and 2. So the rows are the horizontal ones, the columns are the vertical ones. When we're identifying the dimensions of a matrix, we use the number of rows and then the number of columns, and it's written with this X in between, meaning some number of rows by some number of columns. So this matrix up here has 3 rows and 3 columns, so we would call it a 3 by 3 matrix. First, we're going to talk about adding and subtracting matrices. When you're doing that, all that you need to do is find the corresponding elements in each matrix, the ones that are in the same position, and use your operation. So here, we've got 3 plus 4, that would get us to 7. Same idea with subtracting. Whatever's in the same position, you just subtract those numbers. So like 5 minus 3 gets us to this 2. When we are adding and subtracting matrices, they have to have the exact same dimensions. We have a 2 by 2 here and a 2 by 2 here, so we can add them. We have a 3 by 3 here and a 3 by 3 there, so we can subtract them. If we had one that was, say, a 2 by 2, and then another one that was only a 2 by 1, we would not be able to add or subtract them. They have to have the same dimensions in both matrices in order to add or subtract. So let's just look at a few of the details of this matrix. So it says, what are the dimensions of matrix K? Remember our dimensions, we go row, number of rows, by number of columns. So here, the rows are the horizontal ones. So we have 1, 2, 3 rows, and 1, 2, 3, 4, 5 columns. So this is a 3 by 5 matrix. The next one says, look at a point where the third row meets the fourth column. So here's the third row, here's the fourth column, and we read this as entry K for matrix K, 3, 4, row 3, column 4, and that entry is 2.5. It's in the third row and the fourth column of matrix K. Number 3 says find entry 3.1 in the matrix. What row is it in, what column, and then what is the address? This was the address for number 2, so we're going to write something very similar to this in number 3. So let's find 3.1. Here's 3.1. It is in the second row, and the fourth column. So its address is K, because it's matrix K, 2, 4. Second row, fourth column. Finally, it says, what are the dimensions of matrices that can be added or subtracted from K? Here, remember, when we're adding or subtracting matrices, they have to have the exact same dimensions. So the only other matrices that we could add or subtract would also have to be 3 by 5. Not even 5 by 3. It has to be 3 rows and 5 columns.